Okay, in this lecture we are going to discuss about trigonometric ratios. Trigonometric ratios is based on, trigonometry is completely based on right angle triangles. So trigonometric ratios is also based on right angle triangles. This is 90 degree, and the side opposite to 90 degree will always be considered as hypotenuse, denoted by small letter h. Now wherever the theta lies, theta may lie on this side or it may lie on this side. It depends according to question where it lies. Wherever the theta will be lying in the triangle, the theta is connected to two sides, two dimensions of triangle. The first dimension, as you see here, BC, it is hypotenuse. If you consider this one, then again the theta will be connected with two dimensions. BC is common in both the cases. So that is hypotenuse is common in both the cases. So what does this mean? The other side of the theta will always be considered as the base, the other connected dimension. Okay, here if you consider this angle as theta, then this will be considered as the base of triangle. If you consider this as theta, so this will be considered the base. It depends which one is being considered. So if the largest side is considered as hypotenuse and the other side which is connected to theta is considered as base, the remaining third side will be considered as perpendicular. Now, there are some ratios. We will consider the counting in this order 1, 2, 3. And there are some ratios. First 1:3, then 2:3, then 1 and 2. This means the ratio perpendicular and hypotenuse. This means the ratio base and hypotenuse. This means the ratio perpendicular and base. Some names have been allotted to them. The first one is named as sine theta. The second one is named as cos theta, whereas the third one is named as tan theta. Now their reciprocals. Reciprocal of sine theta is cosec theta. It will be equal to hypotenuse by perpendicular. Reciprocal of cos theta is sec theta. It will be hypotenuse by base. Reciprocal of tan theta is cot theta. It is base by perpendicular. So these are the names you have to keep in mind. And these are known as trigonometric ratios. There are in total of 6 trigonometric ratios. You have to keep them in proper order: sine, cos, tan, cot, sec, cosec. If you observe carefully, all the C are at alternate positions. SC, TC, and SC. SC, TC, SC. This is the order. Sin, cos, tan, cot, sec, cosec. Sin reciprocal cosec. Cos reciprocal sec. Tan reciprocal cot. Okay, so let us go through some basic examples based on the above theory. Let us consider a right angle triangle. Right angled at B, and the dimensions are given as 3 and 4, AB and CB respectively. Now you are supposed to calculate, this one is example 1. You are supposed to calculate the value of sin A, then cos A, then cot A, then sec C, cosec C, and finally tan C. These are the values to be calculated out. Now, before proceeding with the subparts, you must first find out the length of hypotenuse with the help of Pythagoras theorem, as you know. According to Pythagoras theorem, hypotenuse square equals to perpendicular square plus base square. Since we are not taking with respect to theta, in this case, Pythagoras theorem, generally we consider this as perpendicular only. So AC, in place of AC, let it be question mark here. In place of AB, we will substitute 3. In place of CB, we will substitute 4. This gives us 9 plus 16, and that is equal to 25. So therefore, the value of question mark will be equal to under root 25, that is equal to plus minus 5, but we will only consider the positive value. Why, sir? Because we are dealing with the dimension value. Dimension cannot be negative. The length of a side cannot be negative. So we will not consider minus 5. We will consider only positive of 5. So the value of question mark here is equal to positive 5. That is 5. Now we can go through these values. As you can see, the first value, required value is sin A. Here, the angle they're talking about is A. So we will mark here this line. So we will focus on A this time. So if we are considering A part, this opposite side of this angle is hypotenuse, as you all know, and this, since A is considered right now, this will be considered as base, and this will become perpendicular. Now value of sin A equals to perpendicular by hypotenuse. Perpendicular is 4, hypotenuse is 5, so 4 by 5. Then second subpart, cos A. Cos A is equal to base by hypotenuse. Base is 3, hypotenuse is 5. Then cot A. Cot A. Base by perpendicular. Base is 3. Perpendicular is 4 with respect to A. Now they are asking sec C value. So now we will consider C angle. So for when we consider this one, the dimension changes a bit. This will now become base and this will become perpendicular. I hope I am clear. So now the value of sec of C equals to hypotenuse by base. Hypotenuse here is 5 and base is 4. The value of cosec C will become hypotenuse by perpendicular. Hypotenuse is 5, perpendicular is 3. And the value of tan C will be equal to perpendicular by base, and that is 3 by 4. This is how we calculate all these values, required values, according to given question. Let us continue with another example, example number 2. There's a triangle ABC, a perpendicular line dropped from A to CD, meeting at point D. The dimension of AB is given as 13. BD dimension is 5, whereas DC dimension is 16. Now from this given data, you need to find out the values of first part, sine of D, second part, tan of C, third part, sec square B minus tan square B, fourth subpart, sine square C plus cos square C. Now, if you consider this one as triangle number 1 and the other one as triangle number 2, in case of triangle number 1, this dimension is unknown to us as well as this dimension is unknown to us. So if two things are unknown in the single triangle, we cannot proceed with it. So we must go ahead with triangle 2. As for now, you see that AB is 13 and BD is 5. So we can calculate AD with the help of Pythagoras theorem. So applying, you will have to write all the reasons. Pythagoras theorem in triangle number 2. So it will be AB square equals to AD square plus DB square. Now AB square 13 square equals to AD square is to be calculated out plus DB square 5 square. 169 minus 25 equals to question mark square. 144 equals to question mark square. So value of question mark will be under root 144, and that is plus minus 12. But we will consider the value of question mark as positive 12 only because it is the dimension value. It must not be negative. So now we get this value as 12. Now let me remove these numbers because it will confuse you. Now in this triangle, what we observe in triangle ADC, two dimensions are known to us. We again need to apply Pythagoras theorem to find out the third dimension, that is AC. So in triangle ADC, again applying Pythagoras theorem, AC square equals to perpendicular square plus base square. AC square, let it be question mark here. 12 square 144. 16 square 256. Question mark square is equal to 400. So value of question mark will be square root under 400, that is plus minus 20 again. We will consider positive of 20 only. So the value of this dimension is 20. After calculating out these values, now we can go for the ratio part, and that is when they are talking about sine B. So value of sine B, when we consider B, that means this angle. So this is hypotenuse, this is base, and this is perpendicular for this point of time. So sine B, perpendicular by hypotenuse, that is 12 out of 30. This is 12 by 30. When we talk about tan C, now we have to remove all these notations because we are finding for another angle. Now we are focusing on C part. So we'll mark arrows here. This one is hypotenuse. So this one is base. And this one is perpendicular for this point of time. So when we're talking about tan C, perpendicular by base, that is 12 out of 16. Similarly, you can calculate out all the other respective values. If there is a square, substitute the value and then square it and then subtract them. Okay, so let us move on with another example, a little next level question. Example number 3. Given that if sine theta equals to P by Q, then find cos theta plus sine theta in terms of P and Q. This is the given question in terms of P and Q. Now, since in this question you don't have any diagram, you must draw a diagram, rough diagram for your reference. A right angle triangle, let it be ABC. Mark any alphabet, it doesn't matter in this type of question. Consider theta here, then it's obviously this is base, this is perpendicular, and this is hypotenuse. Now, according to the given condition, sine theta is P by Q. So you will consider perpendicular as P, hypotenuse as Q, because the ratio itself is P by Q, perpendicular by hypotenuse. So you mark it accordingly. After that, again, as you see that we don't know the value of AB here, so this is a big question mark. We need to calculate it out with the help of Pythagoras theorem again. So according to Pythagoras theorem, hypotenuse square is equal to perpendicular square plus base square. So that question mark will be equal to Q square minus P square. So question mark equals to under root Q square minus P square. So in place of question mark, we will write under root Q square minus P square. Now we will find out the given value. According to cos theta, base by hypotenuse. So base we just now calculated under root Q square minus P square by hypotenuse, and that is Q, plus sine theta perpendicular by hypotenuse. So the result will be equal to under root Q square minus P square plus P and the whole thing divided by Q. This will be your answer. Okay. Let us consider another example, a little typical one. That is example number 4. Suppose there is a triangle this is point A, vertex A, C, D, and B. Here it's 90 degree. This is X and this is Y. Now we have been asked to find out the value of cot X. Second subpart, 1 divided by sine square Y minus 1 divided by tan square Y. Third subpart, 6 by cos X minus 5 by cos Y plus 8 tan Y. Now let us continue with the solution part. Nothing else have been given. So it's obvious. We have to continue with this X and Y part only. Okay. AC is given as 26 units. CD is given as 10 units. BC is given as 42 units. Now we have to calculate the respective values given in the question. Since CB's complete value is 42 and CD is 10, so we can calculate the value of DB. Yes, we can write CD plus DB gives us CB. CD is 10, DB we don't know right now, CB is 42. The value of DB is 42 minus 10, that is 32. So this is 32. Now, with the help of this dimension and this dimension, we can calculate out this question mark value by the help of Pythagoras Theorem. Now, in triangle ADC, by applying Pythagoras Theorem, we get 26 square equals to 10 square plus question mark square. 26 square is 676. And equal to 10 square 100 plus question mark square. So the value of question mark square will be 576. So the value of question mark equals to, so the value of question mark will be under root 576, and that is 24. After getting the value of question mark as 24, now with the help of 24 and 32, we can calculate this question mark, that is AD. So in triangle ADB, hypotenuse square equals to perpendicular square plus base square. Sorry. Question mark square is equal to 24 square, that is 576, plus 32 square, that is 1024. So the value of question mark square will be 1600. So value of question mark will be under root 1600, and that becomes 40. So this value is equal to 40. Now we can proceed with the calculation part of subpart 1. That is to find out the value of cot x. Cot x, we know that the value is base by perpendicular. So when we consider x as theta, base is 24 and perpendicular is 10. So the ratio becomes 24 by 10. If you cancel out, it will be 12 is to 5, 12 by 5. Now this is how you will calculate all the other subparts.